Mason Park's water witch shows its tricks. That's the Pied-billed Grebe. This is part 1 about their ability to quickly sink underwater. Part 2, in preparation, will document the Pied-billed Grebe's eating habits, which include its own feathers, its foot-shipping behavior, look that up, and its pugnacious behavior towards others of its species, along with a special dance segment. If you subscribe to my YouTube channel, JDW Talks, you will be informed when Part 2 becomes available. These videos are part of my YouTube Field Notes series for Mason Regional Park. This will be the 4th of the series with another on the Grebe near completion. Here's a map you can download showing the main features of Mason Regional Park, which is in the city of Irvine, Orange County, California. I'll put in the show notes website addresses used in this talk. On 18th July 2025, I glanced from the walking trail near the bridge at Mason Park to the edge of the lake and saw a pied-bill sinking vertically and completely under the water, went under the water. I don't think I have ever seen that behavior before, although I had read about it. That started a 2-week observational and photographic study of the grebes at the park. Let me show you a breeding plumage adult pied-billed grebe from July 21st doing the quick sinking. I'll show you this later in slow motion. So here is the grebe. It's called a pied-bill because of the 2-color bill, white with a black stripe. This is actual speed, and let's start it. Pretty impressive, right? How common is this sinking behavior? Ron Dudley, a bird photographer who has published photos of it, felt it was a very rare event. But a viewer of his work stated it was a common startle behavior of pied-bills of his neighborhood pond. I wonder what the density of those grebes were in that neighborhood pond. In 9 field days and over 11 viewing hours in late July, I filmed 85 sinking events from at least 3 different individuals at Mason Park. I think you'll see 10 of those videos during this video. Pied-bills, besides being called the water witch birds, also have nicknames of devil diver and hell diver. Why? Perhaps the answer lies in the way they can disappear from the water surface. Here's a look at the Mason Park lake area. I concentrated my observations along the rocky edge and the bridge. So you're looking at the Mason Park bridge and rocky areas. The rock on the right with my camera bag was one place that I sat and photographed the birds. It's 10 feet from the rock to the concrete edge of the lake. Probably another 5+ feet of underwater rocks beyond. Pied-billed grebes are considered a solitary species. You don't find groups of them in most places. How many were at Mason Lake? I counted at least 14 on July 24th. Let's revisit that July 21st, quick sinking example, but this time slow to 1/8 speed. A caveat, a warning. While you are watching these behavioral videos, other factors may influence the grebe's on-screen movements, such as how steady my handheld filming was, or the possible action of lake waves. Also, there are individual differences in this behavior. So we're going to see this again, and while you're going to be looking at this, try and figure out how to describe it to someone else. Notice in the video the water boils produced during the sinking at the end. What are those from? 1/8 speed. Presumably, things are happening here, and we'll talk about the mechanisms proposed later. And there's what are called boils on either side of the diving bird, the bird going under the water. How to describe this? Let's see if our perceptions meet the reality of the sinking by measuring some parameters from every 2 frames, that's 1/30th of a second, of the video you just saw. I'll show results from 4 measurements that describe the sinking. So I measured on PowerPoint on the screen the tail height above the water, the eye to tail length, and then the eye height above the water. That's 3 of them. And then I also measured the angle of the tail representing the dorsal plane of the rear end of the body during this sinking. So I figured out the degrees. If it's parallel to the surface, it would be 180 degrees. And this is how I did it. I had an old iPhone that still had a useful app that I could figure out angles of tilt. The frame images were transferred to PowerPoint slides. Then I drew lines on the Grebe image, those areas I wanted to measure, and the vertical and horizontal lines PowerPoint lengths were recorded. The diagonal eye to tail distance was measured on the monitor with a millimeter ruler. All these measurements are relative, not absolute. I just wanted to see trends and maybe some comparisons. So those aren't real numbers, but they are from the screen of PowerPoint. So here are some of my findings. So the quick sinking process starts, in my view, when the nape back, that's the back of the neck, and the back junction of the grebe lowers enough in the water to have water flow over it. And actually I set the start a little earlier, as water surface tension and feather waterproofing probably prevented that water flow for a few video frames. And this is the area that I was looking at. This frame shows the area apparently below the water surface hasn't flowed there yet. But this is really the start of the sinking. The distance between the end of the pied-bill's tail and its eye was measured, and initially there was a slow reduction in length which sped up at the end of the sinking. I'll show you the figure from this. This is based, remember, on 30 data points. The data points are 2 frames apart, or 1/30th of a second, as I looked at every other frame of the 60 frames per second video that I was shooting. I had trouble graphing the angle of tilting. Remember, I did that angle tilting device in PowerPoint, as the line chart cut off my high data points. So I had to use their bar chart format to get all the points in. Couldn't figure it out. But the bar chart will work. You can see, and the data indicates that there was a jump in the tilt toward the end of the sinking around the 45th data point. So let me explain this. So this is a bar chart. The bottom axis is the degrees of tilt. Each bar represents 1/30th of a second in the sinking sequence. The start of the sinking is at the bottom, and so as you go toward the top, that is toward the ending of the sinking at the top. And you can see there is a jump right there about something like the 45th data point. So the change in angle of submersion at the 45th data point correlates with the start of the water boils, which is actually, as you'll find out, caused by the feet-leg movement of the grebe. During the sinking, the bird's tail height above the water surface first increased as the posterior end elevated, and then the tail height decreased above the water surface. See a figure of this in a second. But it was the eye height and subsequent head position that was most interesting for this individual. It was relatively constant until the end of the sink, when the head rapidly submerged. That rapid head movement started soon after the water boils were seen on the video. So here we have both the eye and the tail over time. I estimated the eye distance beneath the water surface, because the head went under except for the crown, for 2 eye height data points. That's why I have a negative numbers there. Here's a frame from a late part of the sinking process where the Grebe's head is still elevated while much of the body is submerged. How does it keep its head up there when the rest of the body is going down? Well, that's an interesting question, right? Here next is a sinking video of a non-breeding plumage individual at Mason. Pay attention to the clearly visible neck extending under the stationary head in this video. This is a cute trick. So my conclusion for that is that the pied-billed grebe can actively keep its head position relatively stationary in space as long as it can during the sinking. This reminds me of pigeons. There's a research on these and their bobbing walk. An AI overview indicates that pigeons try to keep their head stationary even while walking to quote, maintain a stable visual image of their surroundings. So basically the head is stable, the body is walking under the head pauses, then move forward, but it's still in the same plane. So let's see that neck extending trick again. This time the video cropped to just the sinking and slowed down to 1/8 speed. Here we go. See that neck? And then you're looking at the boils on either side. What's known about the ecology and mechanism for the behavior? I use an AI search on Google done on July 19th and 22nd, and I'll take those results and merge their answers, and they will be in italics and enclosed by double quote marks. It'll be clear that it came from AI. Also, I will use 2 online offerings by Ron Dudley and parts of our correspondence that I thank him for. Very useful. So AI. The phrase pied-billed grebe sinking refers to a fascinating behavior exhibited by pied-billed grebes, where they deliberately sink into the water in a controlled manner, much like a submarine. This behavior allows them to disappear quickly and without a ripple, effectively hiding from intruders or predators and providing time to swim away underwater to a safer location within dense vegetation. So AI looks around, and this is what they found. Does it work for Mason? Well, there's no dense vegetation in the lake at Mason Park. The Grebes showing sinking behavior usually did not leave the immediate area, but continued to stay and to continue to show the behavior. The quick sinking, as you saw, did produce ripples. The danger to pied-bills are usually other pied-bills at Mason, and the safest place when chased, which is done often, is probably not to dive, which they will do, but to fly away on the lake surface. I'll show that behavior in part 2. Pied-billed grebes tend to be solitary and not very sociable. The density of pied-bills on Mason Lake apparently leads to increased negative interactions of grebe individuals and lots of chasing. So I think one of the main reasons why pied-bills do quick sinkings at Mason Park is to increase their scrutiny of their surroundings for predators and attacking pied-billed grebes, which will attack them from the surface or even underwater. They'll just dive underwater and come up near another individual. So here are types of submersion. There are a number of different types. There's something called, from AI, gradual submersion. The grebe can control how much of its body is visible, sinking inch by inch until only its head or even just its eyes and bill are above the surface, or disappearing completely underwater. That looks like a slower behavior. And then there's slow or quick sinking. They can sink slowly, known as gradual sinking, or when startled can perform a faster dive, sometimes leaving a small disturbance on the water's surface. That's why I was using quick sinking. Ron Dudley used the term gradual submersion for the Pied-billed sinkings. He observed, "I've elected to go with quick sinking for the Mason Park birds. I have reservations and second thoughts, though. Perhaps a better term for this behavior is quick sink dive, because it's not just like a rock going down." I did see on 4 occasions where a moving Mason Pied-billed Grebe only had its head and tail above the water surface. 2 of the events were caught, one on a photo and one on a video. The video was taken at distance, the bird was toward the middle of the lake, and the image blurry. I don't think that the majority of Mason Grebe's quick sinkings are because they're startled, but such situations did occur. So here is a lucky photograph where I snapped one picture without even looking through the viewfinder. It would surprise me, of a bird that just shows its head and tail. And then here's that blurry distant shot at 1/8 speed that I'll show you. So this bird is in the middle of the lake, basically. I don't think it's startled by anything. And it can do that for a couple of fractions of seconds. Here's another submersion definition that AI had, something called crash diving. In a more rapid escape, they can perform a crash dive, pushing their breast down, thrusting their wings outward to propel themselves downward, and kicking their feet to create a splash that can startle predators. And I did not observe that at Mason Park Lake. So let's figure out some possible mechanisms for this quick sinkings. Certainly there should be something that someone has investigated, some scientific paper on it. First of all, there may be a number of mechanisms working together. There may be different mechanisms for the different types of immersion behaviors. They may be different, and some of these possible mechanisms may not work. A problem I found with this online information about mechanisms is that the statements on the behavior are not referenced. Where are they coming from? Repeating other people's repetitions? A search on the California State University Fullerton CSUF Library's OneSearch utility under Pied-billed Grebe found 230 titles. None were about the sinking behavior of the species. There was one reference found on diving times and distances in the Pied-billed Grebe in 1975, but that wasn't applicable. Second, I feel that any proposed mechanism should take into account the quick recovery period. It has to be a recovery period where individual pied-bills can immediately do another quick sinking. It needs to explain why a Mason Grebe, and I timed these from the video frames, can do 3 quick sinkings in 29 1/3 seconds. Another time 4 quick sinkings during 108 seconds, and another time where a single grebe did 7 quick sinkings in a 3-minute period. How can it do that? How can it recover between these sinkings? So here's the first mechanism, which is called water trapping. I call it water trapping. Controlling buoyancy. Pied-billed grebes possess a unique ability to manipulate their buoyancy, which you have seen. Trapping water and feathers, they can trap varying amounts of water in their feathers, which adds to their weight and enables them to slowly submerge. Resurfacing. Conversely, this is the recovery period. Where's the recovery period? Conversely, they can release the trapped water from their feathers and rise back up like an elevator, according to the Sacramento Audubon Society. Remember, AI is just summarizing stuff that it can find online. So my comment is, explaining the behavior by water trapping doesn't appear online as often as an air explanation later. But while we're talking about elevators, and also mentioned in the original article in Sacramento, submarines, let's see how their mechanisms change buoyancy. Elevators, with their external power source and restricted movement, and operating on land, not an analogy that is often used. I wouldn't have used it. Submarines are used as an analogy, or often used to describe the Grebe behavior. But is it really a good analogy? The ship to dive takes on water in their ballast tanks, increasing the density and reducing their buoyancy. They use compressed air to drive out the water, reduce the density, and increase their buoyancy to surface. It takes energy. The submarine doesn't change shape. And when a submarine dives, quote, it maintains a relatively level position despite descending into the water. You can imagine what would happen to the sailors if that didn't happen. So do the pied-bills at Mason do the same thing as submarines? Do all parts of the grebe submerge at the same time? I think you can answer those questions on what you have seen already. I would like a more detailed explanation about feathers and water loading and unloading. We are dealing with a pied-bill fully immersed in or floating on water. How does the proposed water transfer to and away from the feathers or trapped under or between feathers actually happen in a water environment? I did find under different search terms at CSUF's OneSearch a reference that stated the grebe's plumage is waterproof. It spends a lot of time preening and taking oil from its oil gland. How does that impact this proposed water mechanism, if anything? Mechanism 2. Feather air storage. You'll sometimes see this. Expelling air from feathers and air sacs. They also squeeze out the air trapped within their feathers and internal air sacs. We'll do the air sacs later. Allowing them to reduce buoyancy and sink effortlessly. And Ron's comment from his online material says no matter which diving technique they use, they expel air from between their feathers by flattening them, and also expel air from their air sacs to make them less buoyant. This is from one of his online photo essays. I'll give you links to those. And in correspondence, because I asked him about that, he said that the pre-dive feather flattening is most noticeable on the top and back of the head of the grebe. That's where I always look for it. Well, my comment is I didn't see any head feather flattening or back plumage compression of sinking birds. And you can look at that video again. Initially, I thought that the video bird's back was getting flatter during sinking, but superimposing earlier images on the later images of the video of the bird's side view did not confirm that. But that's only one bird and one dimension. I would like to see 3D renditions of the birds to see if the grebes are compressing their surfaces for sinking. There is a paper by Rajan Desai who indicated for ruddy ducks who go through a very interesting mating display, the males, that they strike the beak against the inflated neck, creating bubbles as air is forced out from his feathers. So one can get air out of feathers, I guess, with force. I'll show you that in the show notes. Grebes, when preening, often fluff their feathers, probably trapping air. I saw feather fluffing, though, within a quick sinking sequence only once, on July 29th. The sequence in an 8-minute period of a single individual I followed as best I could was sink, 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 headfirst dive, sink, fluff, sink, headfirst dive. Where's the recovery? Where are all the fluffs? And so this grebe has already made 7 sinkings before it fluffed its feathers. This could have been more before I started following the individual. This is probably in slow motion, although I don't show it here. That probably could trap air. I expect with this air feather mechanism, assuming the ventral feathers are involved, the ones in the water, that a rim of bubbles would occur around the sinking grebe. The videos don't show that. There are some large bubbles right after the grebe submerges with a quick sinking, as well as headfirst dives, but I assume they are the result of the quick sinking, not byproducts of the cause of the sinking. And Ron concurs with my conclusion there. So let's go to mechanism 3, air sacs and internal air storage. Let's talk about bird air sacs. Birds' respiratory system is quite different from a mammal's. Refer to a description elsewhere, and I give you one address there on how birds breathe with their butts. So that's one description you can look at. Air first coming into the system goes to the posterior air sacs, then the lungs, then the anterior air sacs. It takes 2 breaths for the intaking air to be eventually expelled. Complicated system, but it gets a lot of oxygen out of the air. Mechanisms involving expelled internal air in the pied-bill are advanced to try to explain the sinking as a decrease in the grebe's buoyancy by making its body denser. Exhaling air might do that, and the air could be expelled while the grebe's head is out of water and not be visually detected. Observing breathing in birds is not easy if you think about that. With an air sac internal air storage explanation, though, how would explain that the grebe's posterior end, with its posterior air sacs, moves up during the initial quick sinking process? What causes the front of the grebe, which must be toward the center of gravity, to submerge first and the tail end last? Mechanism 4, body compression. This mechanism actually could encompass the previous explanations. I'll repeat here a quote from David Sibley, cited in the website below. By contracting their abdominal muscles and thereby compressing their plumage, while at the same time exhaling, small grebes can submerge themselves from a resting posture on the water surface without diving. Sounds good, but what is a bird's abdomen? AI told me for birds, it's the section of the body located between the posterior end of the breast and the vent, the cloacal opening. Isn't that the area of the grebe, the posterior area, that's initially raised during quick sinking? And the tail, the last to go underwater along with the crown of the head? And what happens to the trapped air in the feathers? Did that before. The problem of the apparent lack of bubbles surrounding the sinking bird. So there's some problems here. A reference search using OneSearch at the CSUF library with different keywords than just pied-billed grebe found that in the behavior of Texas birds, which I actually talked about a little bit earlier, Kent Rylander said, quote, their thick waterproof plumage can be compressed to decrease buoyancy. Mechanism 5, use of feet. And here's my last mechanism, use of the feet of the pied-billed grebe during the quick sinking. AI did not mention that subject, probably didn't find anything that people mentioned on it, but I think it's important. Ron, however, says I've cropped several images that he put online to include the water boils to either side of the bird. You've seen that before, and we're going to look at that more detail. These birds have considerable ability to rotate their tibiotarsus, which allows them to move their feet above, below, or level with their body. so they can propulsively steer in any direction, including down. Those water boils are evidence of that ability, but it didn't go a step further. And so you can see here, this is from the title slide, these boils on either side. Our pied-billed grebe foot and leg movements correlated with the quick sinking movements and the boils. So I'm going to show you the large pied-billed feet, if you've never seen them, a young grebe headfirst dive, and then 3 sinkings in slow motion that show the foot-leg action. The lake has pretty murky water, and so we'll get a feeling for leg and foot actions. So first, here is a pied-billed grebe. It's very rare for them to go get on land, but I saw a few of what you're going to see, which is a rock landing, this is half speed. So I have a handful of these that I videoed. So this is a rock surrounded by water. Grebe comes up to it and says, maybe that's a feeling that maybe that would be a nesting platform, although I don't think they really nest in Mason Park. What's he going to do? Look at those lobed feet. No wonder these birds can't take off from land. In fact, on part 2, I'll show you that those feet are put underneath the wings. And that's called shipping. So here is the diving from the bridge looking down. The green watercolor is the color of the lake's water. The water clarity isn't that great. You can see, you can barely see the end of the feet going down. This is 1/8 speed. This is going to be, the feet are going to add momentum and propulsion for the bird to dive headfirst into the water. And you'll see a little bit of the foot actions in the back. That's what I want you to take a look at. Moves forward, pushes it back with its low feet, and then continues to use that rotation sort of foot-leg action. Very interesting. So now what I'm going to do is I'm going to show you at 1/8 speed 3 different sinkings, 2 of them from the same individual, and take a look at the feet. Watch what the feet do. So this is straight on, basically. It's going to move a little bit so you can see what's going on. There it starts. There goes the sinking, and it's going to increase it, and then the boils are shown. Show you another one. So what I'm thinking is from these videos that the feet don't have much to do with the initial immersion, the initial sinking of the bird, but then it clicks in toward the end, and then it tends to drive the grebe down. So the feet are part of the sinking process. Show you this again. So he's going to go down. The feet don't look like it's doing much here. Now it's starting to work. And watch what's going to happen. They're so close to the surface that the low feet are actually breaking the water surface. And then finally, a third one, which I'm going to show you here. It's another 1/8 speed. It'll start to sink. The feet extend out, and now, whoops, missed it fast. But the feet definitely have something to do with the final immersion of the grebe. So I know from these videos that the pied-bill's feet legs seem to contribute little to the initial sinking, but do contribute to aiding the subsequent downward motion of the grebe once most of the bird's body is submerged. The feet-leg action is close to the water surface and produces the surface boils seen in the quick sinking. So I leave you with a bunch of questions. I have questions. Do you have the answers? Can you point out in my videos any anatomical changes of the pied-billed grebe just before or during the quick sinking? What actually causes it to sink? Can an individual grebe have more than one sinking technique? I'd have to mark them. The reason I know there are at least 3 individuals that have the technique is because they're different plumages. Is there a difference in sinking frequency of paired adults in breeding plumage and non-breeding adults that tend to be picked on more, between young birds and adults, between different water-land environments? What role does grebe population density have on the behavior? Do you know of a mechanism for the quick sinking technique that I didn't cover? Do pied-billed grebes sink like a submarine or an elevator? What do you think? Can you provide a citation to a scientific study on pied-bill sinking that I can access and mention in the show notes? I really would like to see that. So here is information about the photography. The field observations and photography were mostly done early in the morning under cloudy skies, but on the sunny afternoons of the 29th and 30th of July, I was able to film using a polarizing filter to reduce the sun's glare on the water surface and see deeper into that murky lake. The filter also produced more intense colors. Would have been really nice to have a clear lake, wouldn't it? I would find a nearby pied-bill and train the camera on it and start recording. I had plenty of memory capacity. If I observed a grebe during the quick sinking behavior, I tried to follow it and record the next several dives. It often ended with the grebe moving away from aggressive individuals. The grebes didn't have a territory per se. They did defend their personal area around them, especially if they were paired. And so there were a progression of grebes going by this area. All of the grebe photos and videos were taken with a Nikon B700 super zoom camera. That was discontinued years ago. It was on bird mode. The pied-bills were not artificially attracted or called into my photography site. This is a popular park and people go on that walking trails all the time. I handheld the camera for taking the videos and photos. The material has not been edited except for some cropping and clipping of images and videos and some image brightening. OpenShot Video Editor was used to process the media. So I hope you enjoyed that and have some information for me. Remember that part 2 is in the works. I already have the title slide here. If you want to know when it becomes available, please subscribe to the channel, JDW Talks. So this is another of my talks. I have YouTube talks on genealogy topics, census resources, Ellis Island name change myth, immigration, and naturalization. And then I have natural history topics, virtual birding, field trips, birding optics, California birds, Mason Regional Park. I just moved down here in March of 2025. And I expected to have more of these. And then I have interesting, to me, novelty zithers, biology songs, and really surprised me, a very popular YouTube on daybed disassembly. All right, have fun. Bye-bye.